My colleagues and I are publishing this paper looking at a new hypothesis for the evolution of concealed ovulation. And human females are interesting because we don't have any conspicuous cues of ovulation. Some other primates have these sort of very big sexual swellings that attract males, and humans don't have anything like that. There is a slight change in attractiveness that can happen over the ovulatory cycle, but there's nothing very conspicuous that happens in human females. And I was interested in the question of, well, why is this the case? And there's a long-standing hypothesis that concealed ovulation evolved for women to conceal their ovulation from men, and that somehow this would allow for the men to stick around throughout the ovulatory cycle and invest in the offspring for a longer time. And this explanation never really kind of seemed right to me. It struck me that one other possibility would be that women would evolve, or in the past, human females evolved to conceal ovulation, not from men, but from other women. So essentially the idea, which we call the female rivalry hypothesis, to avoid the costs of potential aggression from other women. I created an agent-based model, which means that in this model, we have individuals who are males and individuals who are females, many males, many females. They're actually moving around in this space, and they can interact with one another and choose to mate or not. And then females can get pregnant and have offspring with probabilities that we actually mapped onto the empirical literature from what we know about small-scale societies. So essentially, we have a bunch of males, a bunch of females. They can mate, have offspring, and then I can actually go in to the model and count the number of offspring that individuals with different strategies have. So that is a way of asking some of these questions about the evolvability of strategies without being able to go back in time, right, and look at what happened in our evolutionary history. In the model, not only do males and females have these opportunities to mate and have offspring, but in the testing of the female rivalry hypothesis, also programmed females so that they could preferentially aggress against other females depending on their ovulatory status or their attractiveness, because we thought those were both potential targets that female that we wanted to test in the model in terms of possible ways that females could be preferentially aggressing. And essentially what we found is that if females are aggressing towards the most attractive females, and even more so if they're aggressing towards females that are ovulating, then the females that conceal ovulation do much better in terms of the number of offspring than the females who reveal that ovulation. And so it's what that told us is that this is a viable explanation for the evolution of concealed ovulation. And when we modeled the male investment hypothesis, there wasn't a clear benefit to that strategy. In some conditions, revealers did a little better, and some concealers did a little better, and there really wasn't good support for that as a viable explanation.